Okay, so question 6. A curve has equation y equals ln x over x. Find the x coordinate of the point where the curve crosses the x-axis. We should get this because this is a straightforward mark to start with. Where does it cross the x-axis? If it crosses the x-axis, that is if y equals 0. So we want to know when does y equals 0. Well, that's a simple equation. X can't be 0, so we're left with ln x being 0. Maybe we just know what the result is when natural log of x is 0, but that means e to the 0 equals x, so x equals 1. And there we go, they gave 2 marks for arriving at x equals 1 as you work through that process. Part 2. The points A and B lie on the curve and have x coordinates 2 and 4. Show that the line AB is parallel to the x-axis. Right, I do want to point out, we should have highlighted it at the very start, but there it is. In this question, you must show detailed reasoning. And this is where we're going to get stung a little bit by this. So the curve has x coordinates 2 and 4. If x equals 2, y equals natural log of 2 over 2. If x equals 4, y equals natural log of 4 over 4. One thing to point out, show that the line AB is parallel to the x-axis. It's not about finding dy by dx here, is it? Because finding the gradient at those 2 points, that's not what this is talking about at all. It's not saying that the tangent at those 2 points meets up. It's nothing about that. It's just saying that the y coordinates have to be the same. What a number of you did is now produce a decimal equivalent for those 2 numbers and say the decimal equivalent is the same, therefore. I'm afraid that didn't get you any marks at all. They just didn't accept that. So you have to show that these are the same numbers. So that is, well, let's say that is a half of ln2, which is the natural log of root 2. I think I'm going to write that. And this one is a quarter of ln4, which is ln4 to the power of a quarter. And 4 to the power of a quarter is root 2, so that is ln root 2 as well. So they are the same y value. And AB is parallel to the x-axis. You had to, what they were looking for was that you actually used some of your understanding of logs to come up with exact equivalents for the 2 y values. It wasn't enough to give the decimal. It feels a little bit unfair, but that's what they wanted out of it. And it is a detailed reasoning question, so we can expect to not just stuff things into the calculator and use that in detailed reasoning questions. Part 3, find the coordinates of the turning point on the curve. So if we didn't have to do dy by dx in the previous bit, we definitely do now. So y is ln x of x. If we're going to differentiate this, it must therefore be a quotient rule. We've got a fraction to deal with, so that is v, u over v. So u is ln x, v is x. So it is v times du by dx, so x times 1 over x, minus u times dv by dx, divided by v squared. If I simplify that, that gives me x times 1 over x is 1. Take away ln x over x squared. We've just got 2 marks. 1 mark for doing that, and then 1 mark for saying at a stationary point that's equal to 0, isn't it? So the second mark was for putting that equal to 0. As we just observed, if we've got a fraction equal to 0, the bottom line we can ignore. We just want 1 minus ln x to be 0, which means that ln x is equal to 1. Having just solved ln x equals 0, we know what we're doing with this. This is e to the 1 equals x. So x is e to the 1. The question did say find the coordinates of the turning point. So we need to go back and find the y coordinate. If x equals e, y is ln e over e. We know that ln e is 1. We've just kind of, that was the whole point of doing that. So that is 1 over e. So the coordinates are e 1 over e. That's the point that we're looking for. Part 4, determine whether this point is a maximum or a minimum. The way that we determine whether a point is a maximum or a minimum is we use the second derivative and see whether it's positive or negative. So we must be after the second derivative here. Part 4, remember we're starting from a point where dy by dx is 1 minus ln x over x squared. So the second derivative, we've got another quotient rule to deal with. That is v times du by dx. If we differentiate 1 minus ln x, we get minus 1 over x, minus u times dv by dx, which is 2x, all divided by v squared. X squared squared would be x to the 4, which is, and I don't know how much I want to simplify this, so that is minus x minus 2x plus 2x ln x over x to the 4, or minus 3x plus 2x ln x over x to the 4. You could divide top and bottom by x at this point to have it over x cubed, but I'm going to leave it like that for now. I am interested in the behaviour of that at the turning point. So when x equals e, my second derivative is minus 3e plus 2e ln e over e to the 4. ln e is 1, we've already established that, so that's minus 3e plus 2e is minus e over e to the 4, or minus 1 over e cubed. We're trying to show that this is positive or negative. That's what we're interested in. Well, e is a positive number, so e cubed is also positive, so minus 1 divided by it is negative. That must be negative. Therefore, it is a maximum. And there we are. That's what I would have done, and that would have got all of the marks for that question. And that's maths.